Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Bienvenidos nuevamente a la penúltima sesión de esta tarde. Para mí es un placer presentar a Dan Fay. Dan Fay es nuestro director dentro del grupo de Microsoft Research Connections. El título de su charla va a ser Advancing Environmental Understanding, the Role of eScience. Please join me welcoming Dan Fay.
So I feel like I need to have a grand entrance with a introduction like that. So first of all, let me apologize. My talk won't be in Spanish. It will be in English. So if you don't understand it, you can blame me and come talk to me later. So as Jaime mentioned, I'm going to talk about some of the things around eScience and how it impacts and be used in environmental science and some of the things we've learned over the last number of years on how technology can be applied. My email's up there. Please feel free to contact me. If I don't respond right away, feel free to send another one. And feel free to bug Jaime or Harold or Juliana if you want to get in touch with me. So one of the things I did last year as I was looking at the eScience workshop was I was looking back to see what we had originally talked about 8-9 years ago at the original eScience workshop. And one of the things that kind of came out of it was there was a talk by Jim Gray on 20 questions to a better application and how you can use technologies for some of these scientific insights. And so there was a talk on the also on the online science being the new computational science. And the interesting part is, we're still here 8 years later, and we're still trying to get to that point. I think a lot more of the functionality and the infrastructure is there, and we're getting to that. The other thing that was very interesting at that event, Alex Lay also gave a talk there, and Alex is giving a talk tomorrow, so you'll get to hear some of the updated pieces that Alex will talk about as well. But one of the things that was very interesting in this, and these are some of the slides from the original talk that Jim did, was if you look at some of the challenges and what's going on, some of these are still we're kind of working on and still running into as issues. But one of the things that I always found interesting was the kind of the puzzle pieces down here. That there are different types of people that are needed for working on some of these problems. So in this 8 years ago, the idea was have the scientists, what we called the miners, folks looking at data mining, looking at the massive amounts of data. The plumbers, folks that actually understood how to write some of that infrastructure code and deal with the lower level piece to keep the data actually online or together. And then also the tools to help with what we call the questions and help answer through things like visualizations or other types of tools and technologies. And I still think that that's a key piece today. One of the challenges in academia is some of those roles aren't very well rewarded, even though they're very important. Folks that know how to collect data and actually do a great job of collecting data are priceless. People that know how to do a great job of analysis and understanding of the data and then can find the insights in it are also very key. So how do you actually balance across all those? And do you want, would it be a good thing to actually leverage those people in different ways? So that, this has been in the news forever, for the last number of years, about the amount of data that everyone's dealing with, and we keep seeing more and more of it. So how can we actually take care of it? One of the other things that I always like bringing into some of the talks is some interesting books I've been reading. And these are three of them that I was looking at. And some of it is, are there different ways of actually looking at the data, thinking about it? Is things changing in ways that we need to incorporate into our thinking, both in academia and also in the research just in general? And so just interesting books to read. But a lot of this has led to the kind of concept of the fourth paradigm. And so we're in that area of the data and sense of science. We're getting lots of information data. How do you combine it together? How do you gain some insight from it? And what are the tools and technologies that can be built to enable that? One of the things we look at is, are there ways you can do this and not have to wait forever to get the tools up? Can you do it in what we call a working to working, or you know, it's running, keep incrementing it, keep getting feedback on it? And that's one of the lessons we've learned over the years, was by implementing a methodology like that, going from working to working on these implementations, you may not solve everything right away, but you're having interactions with either the scientists or the users or the consumers of the information, whatever in that space, to actually find out if it's working. And so it's something to think about as people are actually designing their tooling. Don't wait a year to deliver it, deliver something earlier. The other thing that kind of has happened over the last couple of years that we did was, you know, we started working on what was called the changing nature of discovery, and there's a number of these pieces that we were looking at, and all this got put into a overall book, The Fourth Paradigm, which is available for free. You can download it and look at it. But it was written by a number of scientists and some of our researchers, looking at some of the challenges that we see at that point and going forward, how they can actually be maybe possibly be addressed in different ways, and really where we're at in that space. Here's also an interesting piece just on IT. How do you actually implement IT in this new changing world, especially IT for academia and research? So, you know, this is kind of the traditional problem that we kind of been looking at, and still goes back. How does somebody ask a question from these many different types of information sources and get an answer? And not a number answer, but an answer that can actually let them understand more and go into more detail, look for more information, or dive into it. But this leads to many different pieces. How do you share your information? How do you share it in a way that others can consume it? How do they find out about it? What tooling can you use to access those? Do you have to have specialized ones? Can you use generalized ones? There's a lot of pieces that go in there, and that's where some of the effort's been going in to learn from that. Where can some standardization come and some other tooling be made available? So one of the other things I wanted to just kind of place up here was, you know, what is eScience, right? So we kind of sometimes get asked that, and I put up there the definition that Wikipedia has, the one that's from our website. But really, for me, what it means, and it might be hard to read. I see Claudia having her problem. Okay. So what I actually really think it is how does, you know, current and future products, technologies, research assets be applied to some of these challenges to actually further them, right, and help with that scientific insight, but in an easy kind of to use manner. The pace of technology, both on the hardware side but also on the software side, has outstripped the ability for scientists and others to actually track it all and be able to then understand it and apply it into their space. And this is even, we've even seen this in little areas, such as folks that are using Excel maybe are using 2003 and don't actually see what has actually occurred in the follow-on releases. The row limits go away, your ability to have large data sets in there through things like Power Pivot make it essentially unlimited on the data size you can have and have instant access to the information. But because we don't, as a company or others, market these technologies in that space, folks aren't aware of it. And so how do we, this is a challenge we have, how do we actually make sure people are aware of what technologies are even out there, both from us and from others, and how can those be used for science? Oh, there we go. One of the other ones that was quite interesting earlier this year, Jeff Dozier produced an article. It was based on a paper he had written around the fourth paradigm and how he used it and was applied to his work for snow color. So Jeff does a bunch of work on California, looking at the snowpack, understanding it. But the key piece of it was bringing together data from both ground sensor-based ones that he has, satellite imagery, and models and bringing those all together to actually have an understanding of what's happening in the snowpacks. And not just for scientific sake, but because people that manage water in California need to know how much water is potentially there so that they know how they can actually let it go. Do they have to conserve? What is the issue? And this becomes more and more of an issue as we see some of the climate changes happening, and what are we going to do with, how do we apply science in this way? So the thing to sometimes think about is some of the research that happens is not just for the pure research sake and the understanding, but because there's resource managers and others that need to know how to leverage that information for their communities. Another key thing that's kind of been it's come out of a number of these activities is the value of data. And as you kind of see on this kind of graph, infograph type, that the value of it increases as it gets more clean, processed, services are built on it. There's a value to others being able to use it for their science. And when I mentioned earlier about the challenges in some of the academic ways of rewarding folks, people that spend the time actually providing those as services not just don't get rewarded, but you also can't get funded to keep ongoing services even though everyone else needs it, right? People want to just, the funding agencies just want to pay for the new research, not research that's actually being used over and over. So one of the things we've also been looking at is how can we help folks who do provide the higher level services that make, again, the science quicker and faster for others? Are there ways that can help be a self-funding type model? But that's a challenge in working with agencies and everything else on how that can be accomplished. So one of the things I also wanted to kind of highlight is something we've been looking at within the overall what we call the environmental ecosystem, where you have things like what I'll say is the knowledge that you get directly from this planet we have, so the direct science that comes out, and then you have people that want to take some sort of action. Conservation of information, of people, change with the pollution, oil, gas, whatever. There's some sort of action that wants to be taken. Well, one of the things that we've learned in kind of working with some of these projects is that there needs to be a good information connection between both what I'll say is that knowledge side and the action side. And if you break it down a little bit more, folks that are familiar with technology obviously will recognize that these are mostly all technology assets on the left-hand side. You're having some sort of data, the capture of it, the management of it, then you're doing some sort of analysis on it, find something out of it, and then there's this really interesting part, which is the insight, which is a purely human activity. This isn't something that actually happens from any of the programs or others. A human actually sits there and says, wow, I think there's something here, and I'm going to actually write this up, codify it in a paper, and I'm going to publish my information and data. And that's great if all you want to do is kind of keep it within the scientific domain and share it with others. But if you want to have it have an impact with others within this kind of the community, either policymakers, the general public, and others, there needs to be a way to inform them, so communicating with them in a way that makes sense to them, which isn't usually the scientific paper. And also, the credibility for them increases when they can dive back into the data and actually feel that it's real. And it's not just a graph or a video or a slide. So we've been looking at this as well. How can we help with some of these? On the action side, there's also an interesting piece when we were looking at this. So there's the overall communication on it, but then there's another human piece called the decision. So some decision gets made. We're going to do some sort of carbon taxing. We're going to do conservation. And there's laws or other policies put in place. And then there's some sort of implementation. Well, unless that implementation is verified and there's scientific kind of data being captured and actually published back, it doesn't matter. So there's this kind of circular piece of both the communication both ways. And that's kind of where we see the technology fitting, is that ability to help underlie a lot of this and make that more seamless. The ability to dive back into the scientific information and data and see what's actually happening. And the other part that's really interesting when you kind of take a step back even further is that policymakers or elected officials or whoever get bombarded by many different organizations and scientists and people and lobbyists and all sorts of things. And so there has to be ways that you get your message across to them in ways that they can understand. And that's kind of the reality of the situation. Just because you understand what might help, it doesn't mean that that's what's going to happen. If that was the case, none of us would be driving cars because we'd be saving on pollution and we'd be helping with climate change. But there's a reality to how economic development happens. The other couple of other key things that we've been noticing and you've been seeing over time is kind of things like the data flood from the even ecological type information. We're right now in this situation where we have lots of information coming in. You have cheap technology that gets really good precision and accuracy and can collect more and more data, and you can store it away. The cost of storage has gone down. How do you start dealing with this? And it's all being built on essentially commodity computing. But the harder part is actually what are you deriving from it? What is it actually meaning? And that's a lot more where the tooling needs to come in, the visualizations, and other analysis tools. And also new algorithms and new ways to communicate that as well. Folks in the environmental space see this all the time, all the different types of data that have to be dealt with, from hand-won data in the field to automated kind of measurements as well, sample collections, outputs of our models, all these kind of need to come together to help get a better picture of what's actually going on in the environmental spaces. And this leads to what we call, this kind of data integration piece. How do you start bringing all these together from all these different levels, from the spatial temporal challenges of data at different levels, the precision on them, the gap on them, the quality of them, the precision of them, it's all through there. Also, you're dealing with raster points, other types of images. How do you kind of bring all these ones together? And this is kind of some of the projects we've been looking at in different ways. And then why it's kind of interesting is we were doing a project on as Modis Azure project, which was looking at getting Modis data, providing the evapotranspiration information from it over 30 years. So we're pulling the data directly from NASA, processing it, understanding which ones were the cloudy days, which ones weren't, and going through this. Even for folks on the computational side, from our side that were working on it, this took a lot of effort. For the scientists, it was even harder. And we were actually using Azure on the back end, so our cloud computing platform, to parallelize it. And the poor scientist we were working with was really originally trying to do this with just one PC. And so it becomes a challenge. We don't want scientists to have to get to this level to get science-ready data. So that's that idea on the value of the data goes up as it's being processed and made available. And so why is this really kind of key? Is that because really in reality the science kind of happens when you start bringing together all these different data sets from the different levels and actually kind of mashing it up, if you say. And what can we actually gain? What knowledge can we understand from that? And what predictions can possibly be made? So improving the models, but also allowing for other predictions to be made. And then, because we deal with folks in supercomputing centers and others, not everyone has access to all these information, to the large data sets. How can you provide that in a way that scales out to a lot more individuals? So this was a project we were working on the Azure Modis, pulled together many different data sets, the imagery download, even just things like that, tracking the FTP transfers from NASA. Which ones worked, which ones didn't, which ones actually had errors within the data sets. Doing the reprojection, doing some of the other activities, and actually presenting it for the scientists to actually do something with. Then that's actually where it gets interesting. But all this other processing also had to happen just to get to that point. So how do we make that more available to others so that you're not starting from ground zero every time? So some of the other kind of projects we've been working on, the micrometeorology project, looking at putting sensors within the Atlantic Amazon, one of the forests there. Some of Alex's students were working on this as well with us, and researchers. And how do you bring, again, them together and be able to look at some of present the data in different ways? So sensor data in the field, and you're dealing with the battery life, all the other issues. But once you get the data back, what can you do with it? And one of the challenges, especially with sensor information and data, is nature isn't like the lab. Things happen in nature. Animals bite the sensor. Termites will gather around the heat sources. So how do all those affect also the readings and the information that you're gathering? There we go. There's also another project we've been working on, which is this combination of taking some of the biology from the waterways, understanding what the biological processes that are going on there, combining that with the spatial information, and seeing if we can start pulling together data across the world, understanding how the objects, or the life forms within different regions, how do they correlate between them? And so we've been also looking at all these ones. What are the infrastructures that we need to provide this? And so this is something we've been testing out, and now we're actually starting to go forward with even more, implementing those. And you can see different types of visualizations being applied in spatial areas, and even we've been working with some of the folks that provide these drifters that float along in the ocean, and seeing how does that information get, because you're dealing with point sources, how do you apply that within the models to actually visualize that, to actually gain some insight out of it? One of the other things that's really key that we look at, and it's something just in general with data and information, is what we call discoverability, accessibility, and consumability of the information and the data. And you need to have actually all three of them to actually allow someone to do something or do something interesting. And so the discoverability is not just, where is it? Can I find it? Right? Because a lot of times that's one of the hardest problems. And it's not just doing a search, but finding a search of the information you're looking for. The accessibility of it, can you actually get to it? Is it on an FTP site that you need to have a secret handshake to get to? Is it through some sort of website that you have to click a whole bunch of buttons and then try to download it? And then actually, once you get access to it or you can do something with it, what can you really do with it? Is there some sort of technology tooling that can actually pull it in and allow you to do something more interesting with it? And so these are some of the common pieces we work on. And if you don't have all three of them, the data might as well be in a file cabinet. So we've been working on, one of the other pieces we've been looking at is kind of a way to describe this, and we call it the Environmental Informatics Framework. It's more just a way to talk about how to bring these data sets together. So allow data from different data sources that you want to pull from it, and sharing it, and bring together everything from, make it easier for people to do. But really kind of allow that information to kind of go back and forth and get to the access to it. And then do it in a simple way. So one of the things we looked at was, where is it at? There we go. Was what kind of applications are out there? What are people currently doing, and what are some of the challenges? And one of the things is there's a lot of different types of applications, devices, trying to have access to all these different data sets. Different smartphones, different types of equipment, and you're having it in different sources. And so is there ways to actually make it easier than this kind of spider web of doing one-for-one to the different data sources? And so one of the things that's been going on is there's been work on the Open Data Protocol. And so we've been looking at that and utilizing that as a way to combine a lot of these data sets together in a simple and easy kind of way to use it, manner. And kind of what Open Data Protocol is really about is it's based off of the Atom specification and feeds. And so it can allow data to be published in a way that can be consumed very easily across any platform. And it's implemented in such a way that can be, or designed in such a way that it can be implemented on any platform. And one of the things we've learned over the last number of years with the internet just in general is simple to use and implement specifications are the ones that get most widely deployed. And so one of the reasons why we're really interested in in leveraging on some of the work on the Open Data Protocol is because it is simple. It can be implemented on all these different platforms, and it already there's SDKs on different platforms. And it gives you information now, something you can do now, not waiting for the solution that's always just around the corner. And so this has been very interesting that we've been looking at it. They've just added geospatial data support as well. So that helps, especially in some of the areas that we're looking at with environmental space. And so we've had a number of projects that have been kind of leveraging this infrastructure and going forward with it. And we're constantly kind of looking for places where it could be utilized. And really all it's doing is allowing that on-the-wire protocol to allow interoperability across these data sets. And one of the things that even just I like about it is it gives you at least information about the data, like the data type. So it may not give you all the information or semantic type things that allow you to combine it with anything. But for the most part, there's usually data or information kind of, I'll say, embedded, assumed within a lot of different data sets. And so you still need the human in the loop to say, yeah, you know, this data and this data are kind of similar, or for the uses I'm going to use it for, they're similar, and I'm actually going to combine those together and mash them up. So it gives you that ability to do it. Just even knowing that, that what the most common format that people send around to each other is CSV that gives you no information on data type. At least this is a next step up that allows you information that you can start consuming it much quicker and actually doing something with it. And so there's some other technologies that are coming out of Microsoft in different areas. One out of the SQL Azure labs, looking at what's called Data Explorer, the ability to combine some of these data sets together and mash them up and actually change not just change them, but the values, pull from OData data sets. This is something that we find really interesting, and we've been looking at it, how it can be used in some of these other environmental projects. If you're interested, you can go up there and sign up for an account as well and try that out and see if it will work. There's both a version that runs locally on your machine and also a version that runs directly in the cloud as well. So it's something kind of very interesting to try out. And they're looking at, you know, the same kind of things we're looking at, which is how do you manage the data sources, you know, kind of enrich it by combining them, mashing them up together, and cleaning them up if you have to do some transformation on them, and then being able to publish it out. Oh, and in some cases, on the business side, they're looking at how you could actually make it available for, let's say, for sale, but you could also have it as a snapshot, so somebody can just play with a version of it, or you can have it constantly as a live feed. One of the other challenges we kind of look at, especially on the scientific side, is this whole challenge of you know, with more and more compute being available, so more models get done, more computation happens, the storage going down, more people creating new storage or storing away more information. Does it get used? And so while we can always save more and more of it, if it never gets used, is it really that valuable? And so there's that interesting balance there. And so providing some other information on it, maybe making it more available to others, could be a way to help with it. The other interesting part is, are there other ways to data mine that information? So either collected information or model outputs or other ways of dealing with it. There was an interesting project that ran across at the University of Minnesota that was data mining on MODIS data sets, imagery over a number of years, and what they could start telling from it was, between the imagery, was where fires had happened, where, in the case of the Amazon or others, where logging had happened and clearing, and you can start seeing some of these changes based on vegetation and other parameters. But it was really just applying some of the machine learning to it to actually look at these data sets over time in the same area. And so, you know, that's one of the reasons why we kind of look at, are there ways that you can share this information out earlier or more often so that others can actually consume it and maybe find some other use of it that you originally didn't think it was designed for. So we also kind of look at, you know, new ways to analyze and communicate with the information and data. There's been some work within Microsoft in our European organization that's been working with folks in the EEA and others around the world on this Eye on Earth project, which is a way to bring in other information and data, and both consumer ones, but also process ones from like the EEA. And they're creating more of these, what they call network watches. You can go out to the site and see what they're doing, but it's a kind of an interesting, again, model for bringing together data sets and making them available to the public. So again, how do you make that, connect that communication part and inform people on the data? We also have a group in our lab in Cambridge in the UK that focuses on computational ecology and environmental science. And so there's a bunch of work that they're also doing on model outputs and model development and some other interfaces. And both I wanted to highlight their website there, but there's some other interesting papers and activities going on there. And one of them they've been looking at is a global carbon feedback model, helping bring in more of the uncertainty into the models, and actually can you start combining different pieces of the different models together so that you're having an apples to apples comparison rather than what happens on a lot of the models. The energy actually isn't preserved in a lot of the models, and so you have actually divergence on them over time. And so that's not really a good thing. So how can you start applying some of the same rigor within the models, across the models, applying different pieces, and accounting for a lot of the uncertainty that's actually happening? And they're actually looking at this overall component framework where we have some different pieces. The fetch climate activity, which allows you to pull data set out of a certain region over time. So one of the challenges has always been, I just want data for, say, Brazil or for Mexico over the last 30 years in just this region. I don't want it for the whole world every year and pull it. So this allows you to get your data in that data set. And if you go to do a search on fetch climate, there's a website there that you can actually test it out and utilize it. And it works against a lot of the carbon climate model outputs that are already out there. And there's some other activities. I was going to show the dataset viewer. You can bring in netcdf files very quickly, slice them and dice them and visualize them very quickly. And so again, how do we make that easier for folks to utilize? And this kind of just a screenshot of it. The website down there at the bottom actually has a link to all the tooling that's been coming out. But you have the fetch climate upper left. You have some of the Filzbach, which brings machine learning and some Bayesian networking to applying to the different data sets you might be putting in. And then some other data set viewer on the lower left. So we're always looking at how we combine these together in different ways and allow easier access to the scientists. A couple of the other things, I'll just cover this really quickly, that I've been really interested in lately is just the overall complex event processing piece. So bringing together streams of information very quickly and be able to analyze those. And can you process a lot of it very quickly, detect some of the, the patterns within the data sets. And while we have this Insight project, Microsoft Insight project, which comes out of the SQL team, we've been looking at it not just for stream flows of data. So we have a project down at USC where they're actually taking traffic information and data and making determinations on the fly based on not just historical information, but ongoing ones, even on side street and other pieces. So they're actually able to use light information, light changing data. But one of the things that we actually see is really interesting is this can also be used against historical data and files. So you can run it against large file systems or large databases of files or file sets that are out there. And the query you're sending to it, maybe you're looking for a gradient change of a certain value over a 2-minute window followed by another change in another value over 30 seconds or in a certain time window. The latency on that query is actually from, you could do it if you place it right next to the file, from the disk read to that running of it and back. So you're not shifting a whole bunch of data all the way across the network or to a computational engine to do it. So are there ways to help filter through some of this information and find some of those maybe needles in a haystack that you're looking for and trigger it off of other ones? So it's been an interesting piece that we've been looking at and trying to see how to apply it better for some of these environmental spaces. And we'd be interested in others that might be interested in that. So the last piece I just really want to cover is some of the visualization portions that's been going on. We have a project called NodeXL that's been out for a number of years. It was originally designed for looking at social information, social graphs, but social graphs are nothing more than directed graphs, which is used in a lot of other data sets. Protein interaction graphs, things like that, are all just types of network graphs. And so one of the ideas on this was, could we put this ability into something like Excel to allow that to be very easily done by anyone? Be able to do some of this analysis and the visualization on it, and create visualizations kind of like what you see. And so it's directly in Excel, and you can download that and plug that in. And again, it's for any kind of data set. They'll pull from your email, they'll pull from Twitter feeds or Facebook, but you could also apply any other information as well. It handles clustering, subgraphs, a whole bunch of other functionality in there. And you could also put in the other images and see what's in there. So one of them that's kind of near and dear to my heart, because it sits in my team, is the Worldwide Telescope. So we originally were working on it for visualizing astronomy-based information, sky surveys, other data sets, and being able to visualize those, and not just visualize those in 3D, but also add in the temporal piece, but also kind of create a way to communicate that information through what we call tours. And a tour, unlike a video, right? So a video is a linear progression of something you've decided to show someone. If you stop it, you pause it, you just start it up again from where they left off. You're not getting any other diving into the information. So when I was talking about the ability to dive back into the information and the way to actually, when you're communicating it, the tours we have allow you to pause at any time, dive into the information in more detail, right-click on it, get more information on it, and then start it back up again and continue the tour. So with both audio and video and others, or not video, but audio and imagery. So it's a way to communicate information and data. And we see this as a really interesting way of communicating to others. And Alyssa Goodman, one of the researchers, scientists at Harvard that's been involved with us from the beginning, said she's actually had more people watch her tours that she's created than have ever read her papers. And so it gives you kind of an idea of this, how do we appeal to other folks and a broader set of community and can we bring in some of this new media in a way to communicate scientific information and data? We've also added in an API so you can actually push information into it and visualize it. And we have a piece in Excel so you can just upload data as well. And it uses just a web-based API, so it can be done for anywhere. But the other thing that's been really interesting, it's not just for astronomy. We've been doing a lot with Earth-based data and information. And so, we bring in all sorts of different polygons and data sets and using some of the standard geospatial types from like well-known text and others to visualize it. And one of the things that we actually can do that some of the other globe can't do, the virtual type globes, is visualize information below the surface as well as above it and actually at the polar regions. So we're really interested in how those can be utilized for other scientific insights. And along with that, we created what we call Layerscape, which is a site to not only share some of the data and the information in these tours, but one of the things that's kind of an outcome of this is if I create a tour with the data and the information, when I hand that to you or hand the link to you to that tour, I'm also handing to you the link to the data or to maybe a subset of the data right away. And what this has kind of enabled is now a way to share information through this kind of token of in this case, a visualization. We really wanted to the thing I really always wanted to get down to was the ability to have a graph on a site, and I like the data, or I like the way the data is visualized. I want to rip the chart so I can apply my data to it, or I actually want to use that data, combine it with my data. And so we see this kind of as a way to start getting to that as well. One of the other things we've also had fun with over the last number of years is applying things like Connect to interacting with the information and data. So since we have something like Worldwide Telescope, we integrated in the Connect, originally for Xbox and now for the Connect for Windows. to allow us to actually play with the data and again, play with the interface so you don't have to actually just be at your desktop or on a small device or others. And in fact, we've even done it on a 10 by about 20, 25 foot screen. And it changes your perspective on how you interact with the information and data. And so we see this as a new way for folks to, in the environmental space, to actually start doing that. So a couple other things I just wanted to get people thinking about before I finish up here was about the overall data storage sustainability. So one of the things that always keeps coming back in my mind is, you know, having digital data and having it open is a great thing. But at the end of the day, they're still spinning disks. There's still electricity being consumed. There's still maintenance, all these other things, disk break. And it's an interesting thing of where does that actually, the cost get covered at. And so one of the things we've been looking at is, are there ways, models to help with that? You know, in some areas you have things like tolling. Is that a way to do it? Is there, like you have in a lot of countries, TV licensing, where you pay to actually have a TV and accept the broadcast? You know, it's not clear what the right thing is, but it's also not clear to me that either just advertising is going to be the way to support all of these scientific information and data. And so are there ways that we can have self-funding ways of supporting some of these systems? I don't have an answer, but it's definitely something we kind of keep looking at and trying to understand, especially as we start getting more and more of these data sets up there. Again, there's kind of no other, for some of these challenges, no silver bullet right now, but where there's a whole bunch of areas that can be applied that still need pieces in here so that start thinking about the data and retention earlier. One of the challenges when I talk to a lot of the folks in the environmental space is that they do a great job of teaching people how to actually capture physical data. They don't do a great job of doing it with digital data. So we need to start putting in those types of things and teaching people from the beginning how to do that. And since my time's almost, I'll skip over this one. And just the last thing real quickly, in October, we're having our eScience workshop. It'll be in Chicago. I have the link up here for the website. The call for sessions and kind of proposals for talks are up there. We want to bring in all sorts of different activities. You know, like in fact, one of them, the Live Andes talk I saw today is a good example of that, bringing together technology and science and how you can actually utilize that for scientific benefit. And so these are the types of things we'd like to see there. We invite all of you to submit, talk, come, and it's a good opportunity to collaborate with others in other domains as well. So, done. So thank you. I appreciate it. If you have any questions, feel free to nail me after the thing, because I think we're ready to move on. And again, my email is dan.fay@microsoft.com. So appreciate it. Thank you.
Thank you, Dan.